Now, the last thing we're going to talk about are other forms of sampling techniques. So we kind of focus on experiments, but we can also do observational studies, right? So a lot of times we're doing surveys and things like that. So a census is a count or measure of the entire population. Taking a census provides complete information, but it's often costly and difficult to perform. I will also caution to that that's a vocab word census, okay? So if I'm a company, we've seen this example before, I'm looking at maybe the salaries, so how much I'm spending on salary each year, that would be a census, right? An example where I could have the information for every single employee in my company. When we do the census in the United States, yes, the theory is that we're getting every single person, right? So everyone has that job to send that census back in to say, yes, this is how many people who live here and so on. Realistically speaking, though, even that census, there are people who do not fill out that form and respond. Some are just due to forgetting, so they may forget to fill it out. Maybe they didn't receive it in the mail. Others are because they could be homeless as well, so they may not be counted in the census because they do not have an address to receive mail at. Or they're more transient as well, so maybe they've moved a lot. So again, maybe they did not receive that census in the mail. So we just want to be careful. So here, census is a vocab word. And when we use and take that census in the United States to see how many people live in the area, yes, the goal is to get every single person. But realistically, it doesn't happen. So just kind of keep that in mind. A sampling is a countermeasure of part of the population, so we've talked about samples, and is really much more commonly used in statistics. However, the sampling must be representative of the population to occur accurate results. And sampling error does occur. It's the difference between the results of the sample and those of the population. So your sampling error is really that difference between what you get for your sample data and what the answer really should be if I had the whole population data. And everything has error. So we will talk about later in class how to minimize that error. But there's always going to be usually some sort of error. It's almost inevitable. We do our best not to have too much error. So there are ways that we can minimize it. And we'll talk about that in class. So the best way to survey and sample is to do random sampling. So a random sample is one in which every member of the population has an equal chance of being selected. Okay. So everyone has an equal chance of being selected. That is a random sample. Deeper than that is something called a simple random sample. And again, it's also true that every member has an equal chance of being selected, but it's also true that every possible sample of the same size has an equal chance of, being selected. Now, for our purposes, I don't want you to stress too much about random versus simple random. But let me give you an example. A simple random example, the classic way to think of it is to pull a name out of a hat. Right? That kind of theoretical idea of like put all the names in a hat, pull a name out randomly. That is a simple random sample. So if I were to survey US adults, right? Theoretically, every single US adult would be in that hat, and I would just randomly pull out however many I need. That is the absolute best way that you can sample. It can be very difficult to do though, so it may not always be relevant for that project you're doing, but that would be the absolute best way. Now, a random sample, or we're going to see different ways that you can randomly sample in a second, just means that everyone has an equal chance of being selected. So for instance, let's say we were in the classroom, and let's say I had 4 rows of students. I could randomly select one row to be part of my survey. Now, I'm going to choose that whole row. So I don't really have it as simple as this case where I'm not pulling out each name individually. I'm just pulling out which row I'm going to sample. So I'm still being random because each student has an equal chance of being selected, right? So I could pull either rows 1, 2, 3, or 4. There's an equal chance of that happening. But it's not the same as pulling individual names. I'm kind of grouping people. So that's the difference. So random samples can still occur even if you group people together. We're going to see some examples of that in a minute, or have a more systematic way to do it. But your simple random sample kind of is back to when we were little and pulling names out of a hat, right, to get groups. So that's your simple random sample. The other thing you have to think about, and we'll talk more about this with probability, is that you do have to decide if a population member can be selected more than once. So if they can be selected more than once, we call this with replacement. So theoretically, if you pull their name out, you would then put her name or his name back in the bag, and then they could get chosen again. So a lot of times they'll do that with fundraisers. So let's say you bought like a raffle ticket for a fundraiser. Some fundraisers may say that you get a chance every single time. So even if you win prize number one, they'll throw your name back in the bag and you could win other prizes, right? So that is with replacement. You're replacing that name back in the bag. Other examples are without replacement. So let's say, again, think about that raffle. If you win once, then now you're done. You cannot win another prize, right? So that is without replacement. So there's different ways to think about this. But again, the best strategies are simple random. So if you can do that kind of same idea of like just randomly picking names out of a hat, that's the best thing you can do. It just may not always occur that way. So here are some other sampling techniques. Okay. So, and these are still random. So these are not simple random, but these are still random. So first is a stratified sample. Okay. So what we do here, this is actually similar to block sampling that you do with an experiment. So very similar. I'm just finding my examples so I have them ready to go. So it's very similar to block sampling. So what you do here is you first group members of the population. So members are divided into groups called strata, and then you randomly select from each strata some people to be part of your survey. So the example in the group, in the text, excuse me, has three groups. They have group one, which would be low income households. They have group two, which would be middle income. And then they have group three, which would be high income. Okay. So these are your strata, group one, group two, group three. These are your different strata, right? They're just different groups. See if I can focus that a little bit. There we go. And then you have houses here. So I'm just going to draw a couple little quick houses. And then what you do is you randomly select from each group. So now you're doing random. So you group them first, but now you're going to randomly select. Okay, so you're going to put like these names in a hat first and pull out so many, these names in a different hat, pull out so many, and then these names in a third hat and pull out so many. So maybe I randomly select these two houses, and then these two houses, and then this house. So I'm randomly selecting a little bit from each group. So that would be a stratified sample. It's still random, but it's not simple random, right? So we're grouping first. Now, the second idea is a cluster sample. It is quite similar. So you're going to, again, group. So this usually happens when populations fall naturally into subgroups, and we call these clusters, each having similar characteristics. And then we randomly choose one or more clusters, but the difference is we choose all members in that cluster. So you take the whole group, okay? So there's an example in your text using different zones. Like, let's say, like if we broke down Massachusetts into different counties, so maybe selecting the entire county randomly. I'm going to use my example that I did with the rows. So let's say I have a classroom and I have row 4, row 3, row 2, and row 1, and I have my students in my rows. Okay, so all these little rows have, however many students in it. Theoretically, they should be the same, but they're not always exactly the same. Okay. So what we do is we randomly select one row, or I could do more than one. I just don't select all of them, but I would do it randomly. And then I take the entire group. Okay, so these here are called your clusters. So you group first, and then randomly select an entire group. Now you can select more than one group too, right? So if I was doing, if I had a much larger class, maybe I had 10 rows of students or like a lecture hall, maybe I would take like 3 rows or something like that. So you can take more than one, but you take the whole group. And again, this is still random. It's not as good as simple random because notice, because I'm grouping, even though everybody has an equal chance of their row being chosen, I don't have all different combinations. So my samples are either going to be this row, this row, this row, or this row. I'm not going to group these students together. I'm not grouping these students together, right? I'm not grouping students randomly in different rows. So it really narrows down into groups here instead. Okay. Another way that we can do random sampling, but again, with a more of a systematic approach here, kind of more of a grouping approach, is called systematic sampling. And then what you do first is you kind of assign everybody in the group, everybody in the population a number, or put them in some sort of order. And then you pick a number to start at randomly. And then you select at regular intervals. Okay, so a great example of this is maybe we want to survey people who come out of a grocery store or people who are coming out of the MAT143 building or something like that. So what happens is everybody gets a number. So I don't know, we'll just draw a couple people here. Should have drawn my people before the video, make it a little faster. Now, obviously, your population can be much larger. So if you're talking about the United States, you could have millions of people, right, that you're trying to survey. So I'm just doing a few people here, and they'd each be kind of put in order. It doesn't have to be random order; it could just be any order. It doesn't matter. Random order would be best, but you have them in some sort of order, right? And then you randomly pick a number to start with. And your calculator, as well as computers, can do random numbers. So there's random number generators. So you don't want to just pick one yourself. You don't want a human to just randomly pick a number. You want like a computer to pick a number. We actually have bias when we try to choose random numbers. So humans really can't do it. They may try to do it and think they're choosing randomly, but they don't. So you want to have like a computer or some sort of technology to pick a random number. So maybe our random number is 4 that we start with. And then you choose the interval that you want to survey. So maybe I'm going to do every third person. So I start with 4, and then I would do 1 to 7, 1 to 10, and so on. Okay, so the random part comes in with who you start with. So any person can be the person that gets started with, and then you choose the interval. So are you going to survey every 10th person, every 5th person? It's really going to depend on your population size, right? If you're dealing with millions of people, then you can't do every 5th person. If you're at a store and you're trying to survey people who are shopping there, then yeah, maybe you do like every 3rd or 4th person or something like that who exits. So you choose the interval and you start with a random person coming out. This one's a little bit harder to keep random. So we do want to be careful. A lot of times, if someone's shopping at a store, you want to make sure that they really are randomly leaving. If you're getting groups of people who are friends that are shopping together or something like that, then it's not really random. So you do just want to be careful whenever we do this, that our groups are done correctly. And particularly with systematic sampling, that it's not becoming a convenient sample or a bias survey. So this works when ideally people are randomly ordered as well, but that you're not having a pattern, right? So if let's say you're at the Mount and you're trying to survey people, but you only wait from like 1 to 1:30 p.m. and you're like, oh, I'll just survey every other person that comes out. That may not be good because maybe there's a specific class that gets out. So maybe a bunch of math classes get out at 1 o'clock or something. Then you're not really getting a random enough sample because really your group is not random, it's math people, right? So you just want to be careful, particularly with the systematic sampling, that as people are leaving or people are placed in order, that it's still random. Now, a last kind of sampling, and this one is bad, so don't do this, is called a convenience sample. And as it says there, a convenience sample consists of numbers that are easy to get, right? So one example could be is I'm running some research and I only survey the students in my classroom, right? That's really convenient for me. Or I'm doing a project and I only survey my friends, right? So, oh, Professor Paula assigned me a project. I got to do a survey. I'm only going to call my family and friends, right? That's convenient. So that's not a good sample. Another thing that is a bad convenient sample, although your book doesn't talk about it, so it's important. I wanted to bring it up here because it's something you should know. These are called voluntary response samples, or you can also call them self-selected samples. And that's when subjects can choose whether or not they want to do the survey or participate on their own. Now, that's a little bit different than you getting a phone call, let's say on your cell phone, and being asked to participate in a survey because you were likely randomly selected, right? So you always have the choice to say, no, you don't want to participate. So that's not this. These are things like, for instance, if you see a magazine and see a survey in a magazine, and it's like, hey, go to our website and answer the survey. That's a voluntary response survey. That's a self-selected survey. So basically, they put the survey open to everyone, and you just choose if you want to take it or not. What happens is that people who volunteer to take surveys like that tend to have very strong opinions on the subject, and they bias the data, right? So think about it. I'm a busy person. I think you guys are all busy too. I don't have a lot of extra time. So if I'm going to take the time to sit down and do a survey, I probably have a strong opinion on it. So those voluntary response surveys, those self-selected surveys tend to be biased, and they're another form of convenience survey. And I just want to show you that one last link here. Let me bring it up. I don't get it anymore, so I don't know if they still do it, but I know I used to get Women's Health magazine. And at the last page, there was always a survey results of like the average American woman or something like that. And that's a great example of a voluntary response survey. So to answer that survey, you had to go to their website and answer the question. So it's not the average American woman. It's the average American woman, theoretically, right? I guess it could be a male that answers too, right? Or someone else that reads the magazine, right? That knows to go to the website, that takes the time to go to the website. So it's really not the average American woman. It's the average person who chose to take the time to answer the survey, right? So magazines are a great one that you can find a lot of those self-selected surveys. So here's just, again, another link that kind of goes through this. And I just thought they had some nice examples. So let me scroll down. All right, so one classic example of a voluntary response survey would be American Idol, or any of those competition shows like Dancing with the Stars where people get to vote. So in American Idol, the singing competition, viewers get to have a say and vote for contestants via the mobile app, online, or via text. Viewers can even vote more than once. The results are really biased, right? Because it's just like an open voting system. Whoever wants to vote can vote. Nobody is randomly selected to vote or give their opinion. So you figure these are people who watch American Idol. These are people who love American Idol, right? So for me, personally, I may click it on once in a while, but I'm not as into those kind of contestant-based shows. Personally, they're just too slow for me, if I'm being honest. So I don't participate, but there are some people who really love them, and those people who are going to participate. And if they participate more than once, right, these people have very strong opinions on who they want to be the winner. It's not necessarily representative of the entire American population. It's representative of those who watch the show and care enough to actually vote. So that's a voluntary response survey. That those results are biased typically. A lot of times we see these on social media. So if you see surveys on social media that are just asking you for your opinion, again, those are voluntary response surveys. Usually they're on very passionate topics, things like gun control or abortion or immigration or police brutality. So people have strong opinions and they take those polls. So again, those polls may not represent the entire population. They may represent just that small group who has chosen to participate. Okay, so a lot of times, again, those surveys do not represent the population. They often tend to be biased. They are easy to gather in data and get access, so that's why we do them, right? They're fun. They're easy to get information, but they really are not good data. And of course, they can result in errors as well. So just something to watch out for. Whenever you see survey results on the news or in a newspaper or something like that, think about how is this survey conducted? Was this a voluntary response survey? Was anybody just able to respond that wanted to? Or was this a reputable company? For instance, the Gallup poll, Gallup, is an organization that's been around for a very long time, and they are very reputable. Not that everything they posted is always 100% accurate, because things in statistics, we can never be 100% on anything, but they are very reputable. So their polls usually are random and well done. So they're a group that you can feel confident in that they surveyed correctly when you get the results. So you just want to be careful when you see these polls on the news or in papers or in magazines. Really think about, where did that information actually come from? Because it may not represent the population. All right, so finally, you are doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling techniques you're using in the examples below, and then discuss any potential sources of bias if there are any. Again, bias is when you have skewed data. It doesn't represent the population. It's leaning more one way or the other, right? Or your opinion has influenced the data somehow, right? So we don't want bias. We want it to be unbiased, which means that it is representative of the population, right? It's not being pulled in one direction or another unnaturally. So first example, you divide the student population with respect to majors and randomly select in question some students from each major, okay? So you're doing all your majors first, okay? So maybe you have your math major, your physics major, your nursing major, etc., right? So you're grouping them first, and then you're selecting some students from each major. So from math, you're going to take some. From physics, you're going to take some. From nursing, you're going to take some, etc. So you're not choosing everybody in the group, you're just choosing some. If you go back to your definitions, up top here, this actually is a stratified sample, right? So I'm grouping everybody first, and then I'm randomly selecting some from each group. So this is stratified. If I grouped first and then took the whole group, that's cluster. Okay, so if I'm just taking some from each group, that's stratified. If I'm just choosing whole groups, that's cluster. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected, if they're randomly selected, excuse me. So this is actually a simple random sample. So this is the best you can be, right? So everybody just gets a random number. So in the class, let's say if I have 30 students, everybody gets a number 1 through 30, randomly assigned, right? And then I randomly pick, let's say 5 numbers out. So that is a simple random sample. I'm not grouping anybody first, and I'm doing it randomly. So simple random. You select students who are in your biology class. So this is definitely a convenience sample. It's not a voluntary response sample, which is a type of convenience sample, right? Because I'm still choosing the people, but I'm only choosing people in my class. So people that I already know. That's very convenient. So that's a convenience sample. This is bad. Don't do this. Right? So that's going to give you biased data, not unbiased data. So you need to find a different way to sample. So think about what your population is. If your population are students at your school, then you need to find a way to randomly sample from the entire school, not just those students that you know.